Welcome to the first module of Machine Learning through Application. We'll begin this course with an introduction to ML. Today's activities will cover the agenda and course overview for this session. We will discuss a business problem related to book pricing, which will serve as a practical example to understand machine learning concepts. The key question we aim to explore is, what is machine learning? We will delve into the key components that constitute machine learning models. Finally, we will walk through an example of a model that can solve the book pricing problem, illustrating how machine learning techniques can be applied to real-world business challenges. We'll start with the agenda and course overview. This course consists of 3 modules: what is ML, core concepts for tabular data, and responsible AI. Starting with what is ML, we will discuss key concepts, the types of ML, the ML lifecycle, and some application examples using Amazon SageMaker and AutoGluon. Then, we will discuss core ML concepts for tabular data, including exploratory data analysis, data engineering, optimization, regression and tree-based models, and ensembling. Finally, we will conclude with responsible ML, where we will focus on fairness and bias mitigation, as well as fair model formulation and metrics. We will discuss how to mitigate bias throughout the ML lifecycle. Module 1 is divided into 5 lessons, building from the theoretical foundations of what ML is, to using the AutoGluon library for a practical problem. In this section, we will explore a real-world business problem related to pricing books. Consider the scenario of pricing books. This is difficult because authors do not always know how much to charge. We need an app that will suggest prices for books. How would you create that? Let's try a simple if-then rule as an initial approach to book prices. We could use the following rule: if a book has more than 200 pages, we suggest a price of $30. Otherwise, we suggest $15. While straightforward, this rule has obvious limitations. Please, stop the video and take a couple of minutes to think about what could go wrong before going to the next slide. A 1,000-page book price at only $30 seems unreasonably low. The rule also fails to consider other important factors like the book's genre and whether it's a hardcover or paperback edition. We could use more complex if-then rules. Consider pricing the book based on its number of pages, whether it is nonfiction or fiction, and whether it is a hardcover or paperback. If the book has less than 200 pages, between 200 and 400 pages, and over 400 pages, then different sets of pricing rules are applied. These more complex rules may be more appropriate than the simple rule of only considering page length. However, there are still many limitations in accounting for the complexities involved in book pricing. Please, stop the video and take a couple of minutes to think about what problems does this present, before going to the next slide. These rules may not be accurate to the real world, do not take different fiction genres into account, or different subjects in nonfiction. They also do not consider author popularity. You need something that scales and can handle complex problems: machine learning. What is machine learning? Classical programming involves manually creating rules. The rules and data are taken as inputs to produce answers. In contrast, machine learning takes data as input and uses an algorithm to automatically learn the rules from that data, producing answers as output. This learning process allows machine learning systems to adapt and improve their performance as new data becomes available, making them well-suited for handling complex, dynamic problems where manually defining rules may be challenging or impractical. Let's dive deeper into how the machine learns. There are 2 key components: data and a machine learning algorithm. The data represents past information relevant to what you want the machine to predict or recommend. The machine learning algorithm is a pre-built mathematical equations that show the machine how to understand your data. The machine learning model is created by feeding the data and the chosen algorithm into the system. The algorithm analyzes the data, automatically discovers patterns and relationships, and builds a mathematical representation of these patterns. This ML model can then make predictions or recommendations when new data is provided as input. Now that we know what ML is and how machines learn, we will discuss some key concepts. As mentioned, a key component in ML is data, which consists of features and labels. Features are measurable pieces of data that help make predictions. A single feature is represented by lowercase x, while a collection of features is represented as a vector uppercase X. Consider the book pricing example. When predicting book sales, a single feature could be the year a book was sold, represented as X equals 2018. A set of book features could include the book condition, month sold, and year sold, represented as a vector X equals good 5, 2019. Features are crucial inputs that allow machine learning algorithms to learn patterns and make accurate predictions. Selecting and engineering relevant features is a key step in building effective predictive models. Labels are the output or target variable that a machine learning model aims to predict. For a single data sample, the label is typically denoted by the variable y. In our example, the target is the book sale price, which could be y equals $30. The most common types of data used in machine learning tasks are tabular data, data stored in tables, image data, and text data. We will be using tabular data for the pricing problem, which may look like this table of month sold, year sold, genre, and sale price. We have discussed both features and labels. In tabular data, rows represent each data sample. Here, that means a book sale. The columns represent each feature and the label. The month sold, year sold, and genre are the features, and the sale price is the label. Features are represented by a vector x, which consists of features x0, x1, and x2 here. Labels are represented by a variable y. Now that we understand ML and the book price problem, let's walk through an example of a model that can solve the book price problem. The goal is to predict a good suggested book price. A weighted combination of features is used to make the prediction. There is a function fx, which calculates the suggested price, y hat, based on the input features, x0 through xn, with their respective weights, a0 through n. The features could include the year the book was sold, page count, genre, and additional fields. In other words, the model makes predictions for books based on their feature values. Let's make this more concrete. Say that the feature denoted as x1 represents the number of pages for a given book. The number 150 is assigned to the x1 variable, indicating that this particular book has 150 pages. Another feature could be a binary indicator for whether the book is fiction, taking the value of 1 or yes if the book is fiction. Weights in this model determine how influence a given feature has on the output. Each feature has a corresponding weight. A 1 is the weight for the number of pages feature x1. This weight could be 0.1 for example. The weight of 4 corresponds to the is fiction feature, x4. The value of a 4 is given as 0.25. For this model, we use these two features to determine a price to suggest. Taking the weights for each feature value, we see that the weighted sum of these two features, 0.1 times 150 for the page count and 0.25 times 1 for the fiction genre, results in a predicted price of $15.25. Note that this example shows how a model can make predictions. We will cover the method to learn these weights from data later on. In the next lesson, we will cover Jupyter Notebooks and how to use them with ML. We will also cover what is Amazon SageMaker and how to use Jupyter Notebooks with it. Thank you for listening to this module.